Let's begin with Rolle's theorem there. Rolle's theorem. Here's what Rolle's theorem says. If we have a function f that is continuous, has to be continuous, on a closed interval, from A to B, and the derivative exists for every point, differentiable, on the open, can't take the derivative at the end point, on the open interval from A to B, and it says, and if f of A equals f of B, if that's the case, then there is at least one number, C, in the interval from A to B, such that the derivative is equal to 0. It has to be at least one number. So the criteria for that, if you look at that statement, f is continuous, has to be continuous, no gaps in it, from A to B. F prime, the derivative, exists from A to B. These are the criteria. F of A has to equal to f of B. If all three conditions are true, if all of them are true, then there is one point between A and B where the derivative at that point, one point, C, between A and B, where the derivative at that point is equal to 0. Has to be one min point or one max. And you can try to think of any other choice. Let's see. Let's take a problem, like a picture, and see. Let's say this is f of x. F of A has to equal f of B, has to be continuous. Continuous means no holes in it, and the derivative exists. You can think of any graph you want to. Same height, f of A equals f of B. This is A right there, and this is B. You can think of any graph you can imagine. What they're saying, there has to be at least one point where the derivative is 0. In this example, this function, you can take the derivative at any point. It is continuous. We don't have any v's in it. That's where the derivative exists. F of A equals f of B. This is where the derivative is 0, right here. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6, there's 7. This one has to be at least one point where the derivative will be 0. We get 7 of them here. You say, well, you drew it that way. I'm going to draw mine differently. So go ahead. So this is A, and this is B. Same height. And I'm going to graph them like this. Well, guess what? There's one point in between where the derivative is 0. Where's that point? Right here, between A and B. You might say, well, I want to draw mine differently. I want to draw mine straight line. It is continuous. The derivative is 0. I'm going to draw it like this. That's fine. Every point there has, on that line, has a derivative 0. Every single point. There is no way you're going to be able to graph one where the function, the only way, if you graph it like this, the only way. You go, I'm going to graph mine looks like this. This is A and this is B. I'm going to go like this. That's continuous. That is continuous from A to B. It meets that criteria. F of A equals F of B. It meets that criteria. Does the derivative exist? Not here. So this test failed. That's why there's no point in between where the derivative is 0. This does not fit Rolle's theorem because the derivative does not exist right there. It has to be derivative exists for every point between A and B. And if that's the case, there will be at least one point where the derivative is 0. So what they're going to give us, actually, to prove it, they're going to give us a function, and we're going to take the derivative and set it equal to 0 and see if that number between A and B. That's how they're going to give you questions to work with. So let's take a problem. F of x equals x squared minus 3x plus 2. And they want us to test it between 1 and 2. From 1 to 2. Use Rolle's theorem here. Well, to use Rolle's theorem, this has to be continuous. Is f of x continuous? Is it? From 1 to 2? Sure. Yes. There's no fraction to make it with holes in it. Yes, it's continuous. Second one, how about the derivative? Is f prime of x exist? As we go from 1 to 2. Well, if you take the derivative of that, what's the derivative? 2x minus 3. Is there a value where the derivative does not exist if you plug it in? No. So is f prime of x exist? Yes. That's condition 2. What's condition 3? Is f of 1 equals f of 2? What's f of 1? F of 1 equals what? 1 minus 3 plus 2, which is what? 0? F of 2. 4 minus what? 6 plus 2. Is that equal to 0? So do we pass test 3? Yes. Then the mean value theorem says, guess what then? There has to be, there is a number between, called C, it's between 1 and 2, where the derivative at C is equal to 0. Prove that now. Well, to prove it, we take our derivative and set it equal to 0 and see if that number between 1 and 2. There's my derivative. Set it equal to 0. Two x equals 3. X equals what? 1.5 or 3 over 2. Is there a number? Is that number between 1 and 2? Yep. There has to be at least one number between 1 and 2 where the derivative will be 0. And we've proven there's one number between 1 and 2 the derivative is equal to 0. But we have to satisfy these three conditions before we can look at that one.
So that also equals C, right?
That's C. C is the 1.5. We're looking for that number. Now, I say we said at least one number. Could be more than one. Let's try another one quickly. F of x equals what? X to the fourth minus 2x squared. And x between minus 2 and 2. We're going to need the derivative. Might as well find it right now. What's the derivative? 4x cubed minus what? 4x. So the first one is f of x continuous from minus 2 to 2. Let's look at that. If you plug in, you look at this, anywhere you plug in, there's an answer to it. Yes. I don't see a value of x. The only time it's not going to be continuous if you have a fraction, you get x in the bottom. Or you get a square root of a negative number. We don't have that here. How about the derivative? Does the derivative exist from negative 2 to 2? There's your derivative. Is there a value for x where the derivative will not be a number? Will be undefined? No. So yes, the derivative exists. And test number 3, what's test number 3? Is f of negative 2 equal to f of 2? That's also a yes. The answer to both of these, because f of negative 2 is going to be what? Is that 16 minus 8, which is 8. And f of 2 is going to be 16 minus 8, which is also 8. So that's a yes. That tells me there has to be at least 1 point, at least one, between minus 2 and 2, where the derivative at that point is equal to 0. Has to be at least one. Let's see if we can find at least 1 point. Could be more than one. Take your derivative and set it equal to 0. Factor 4x out, what's left? X squared minus 1. Can you factor x squared minus 1? X minus 1 times what? X plus 1. How many values where the derivative is 0? We got the 0, we got the 1, we got the minus 1. Are they all within minus 2 to 2? Yes, we got 3 values. Has to be at least one. We found there's actually 3 of them in that one. If we graph that problem, we're not there yet, that's next class. You'll see us graphing these. If I go to graph this, this is what the graph is going to look like for this function. It's going to look like this. Yep, and the points we found, the minus 1 is right here where the derivative is 0. The 0 right here, the derivative is 0. And the 1 where the derivative is 0. There's 3 of them. So you can actually fudge your graph by knowing actually the mean value theorem where the derivative is 0. You have these points. And if you know you're going to start here and you have one of the points there, it must be going up there. It can't be coming down, because if it's coming down like this, then we have a v there, which the derivative does not exist. And for this, there's nothing where the derivative does not exist. So you can't have a v in the graph. not in this one. So that's what the mean value, Rolle's theorem. Now the mean value theorem, which is another page, and we done for tonight. The mean value theorem. Now, a little bit different than the other one. The first two conditions are the same. F of x has to be continuous. Continuous from A to B. The derivative must exist from A to B. The third condition, f of A, does not have to equal to f of B. There's no mention about that. They could be, they don't have to. So if they are equal, that's fine. If they're not equal, that's fine. This one says then there must be, there's at least one point, we'll call it C, where the derivative at C is equal to f of B minus f of A divided by B minus A. There has to be at least one point where the derivative at that point will equal f of B minus f of A over B minus A. Which is really what? The change in y over the change in x. The slope. So let's take an example and see how that works, just like the other one. Here's my example. F of x equals 5 minus 4 over x. We got a problem here. But wait a minute. They're talking about the interval from 1 to 4. This function is undefined where? At 0. We don't care about this. I'm starting from 1 to 4. So from 1 to 4, this function is continuous. So is the first one, f of x, continuous? From 1 to 4? Yes. Now what about the derivative? What's the derivative of that? Let's take the derivative. What's the derivative of 5? 0. Can you rewrite that problem? Instead of the quotient rule. You can write that as what? 5 minus 4x to what power? Negative 1. The derivative of 5, which is 0. What's minus 4 times a minus 1? Plus 4x to what power? Negative 2. That means 4 over x squared. So the derivative is undefined where? Only at 0. That's outside my limit. So is my function f of x, does the derivative exist? From 1 to 4? Yes. So we are meeting the criteria. Then it says there has to be at least one point between 1 and 4. There is at least one point, we'll call it C, that's the value of the function is equal to f of b, the derivative there, minus f of a over b minus a. Now f of b, that's b is 4. So when x is 4, what do we have? 5 minus 1, which is what? Is that a 4? F of a is 1. 5 minus 4, which is what? 1. Over 4 minus 1. Is that a 1? So they're saying there has to be at least 1 point between 1 and 4 where the derivative will equal to 1. Let's take the derivative now, set it equal to 1, and solve for x. Four equals x squared. X will be what? Plus or minus 2. Do we have a value between 1 and 4 where the derivative is equal to 1? Yes. The only one we can use is the plus 2. Why?
Is -2.
Yep. We have to be between 1 and 4. So we just proven the mean value theorem. There has to be a number between 4 and 1 where the derivative in this case will equal to 1. Now, a lot of times that equation might look a little bit different, by the way. A lot of people don't want to write fractions, so they take this equation. If you play with it, mathematically will look like this. F of b minus f of a equals b minus a times f prime of c. Or you might even see it looking like this. F of b equals f of a plus b minus a times f prime of c. I was hoping to do stuff with this. I use this a lot for other stuff, but your book is not doing anything with it yet. But that equation is really that equation, just looks different, you know? So don't be surprised. You look at it, sometimes it looks different. You know? So that's section 4.2. Next class, Thursday, 4.3, 4.4, 4.5. Make sure you do the homework on 4. You do not want to show up